In this chapter, we will cover basic geometric shapes and basic trigonometric functions.
So your math will fall into line. We'll first some old stuff define, like shapes to compare, triangle and square, and functions like tangent and sine. There's definitely a lot of math in this video, and some of it is geometry and trigonometry, so if you're really rusty on those two, take a look at this chapter and use it as a refresher.
This is Pythagoras, lived in Greece in these dates, lived to 75 years, and he's famous for his discoveries of a right triangle. Here's a right triangle. That angle there is 90 degrees, indicated by that, and it has three sides, A, B, and C. The sum of all three angles within the triangle is 180 degrees. Pythagoras famously discovered that the length of side A squared plus the length of side B squared equals the length of side C squared. So, for example, if A equals 4, B is 3, and C is 5, he discovered that 4 squared plus 3 squared equals 5 squared, which is 16 plus 9, which is obviously equal to 25. You'll sometimes see the theorem illustrated this way. And in tartan plaid, it looks like this. There are 6 basic trigonometric functions, and these represent ratios of lengths of sides. If that is angle theta, then the sine of theta is equal to b over c. The cosine of theta is a over c, and the tangent of theta is b over a. In school, you undoubtedly also learned these as the sine being the opposite over the hypotenuse, the cosine adjacent over hypotenuse, and tangent opposite over adjacent. And there are 3 reciprocal functions. The reciprocal function of the sine is the cosecant, in this case c over b. The reciprocal function of the cosine is the secant, c over a, and the reciprocal function of the tangent is the cotangent, a over b. Let's focus on the sine of theta. In this triangle here, this is side A, 5.2, side B is 3, side C is 6. If we wanted to check to make sure this was in fact a right triangle, we could validate that by looking at our Pythagorean theorem and would find that 5.2 squared plus 3 squared equals 6 squared. This is angle theta. In this triangle, theta is 30 degrees, so we ask ourselves, what is the sine of theta? This simple calculator can quickly answer that for us. That's our number part of the calculator. Those are our trig functions, and we can select either radians or, as we want in this case, degrees. We type in 30 and hit sine. And our answer of 0.5 or 1/2 pops up. So our sine of 30 degrees is 0.5, and in this example, we've gone from a known angle to an unknown decimal value. It's equally valuable to be able to go from a known decimal value to an unknown angle, and we'll illustrate that with the triangle on the left. Supposing I know that the ratio of side B to side C is equal to 0.072. My question is, how many degrees is angle theta? This is an inverse trigonometric function. The question is asked this way: what is the angle whose sine is 0.072? And that is known as the arcsine function. So I'm looking for the arcsine of 0.072. The arcsine of 0.072 is also equal to the sine to the -1 of 0.072, and that is an equivalent way of referring to the inverse trigonometric function for the sine. So I type into my calculator 0.072 and push the A sign or arc sign button. That gives me the angle of 4.12 degrees. So my arc sine of 0.072 is 4.12 degrees. So angle theta is 4.12 degrees. Remember that on your calculator, these inverse functions may appear as -1 exponents.
I hope that short review was palatable to you. As you watch this video, you'll see many times the use of geometry and simple trigonometry.